Hello, everyone, and thank you for attending Lab Manager's Safety Digital Summit. My name is Mary Beth DiDonna, and I'll be moderating this discussion. Lab safety is a non-negotiable aspect of management since a moment of carelessness can result in tragedy. Thoughtful lab safety programs protect personnel, equipment, and products. Adhering to a lab safety program keeps the lab running smoothly without costly or dangerous interruptions. Lab managers must develop a toolbox of useful skills to not only create and implement a lab safety program, but also promote staff compliance to these guidelines. Welcome to this session, Acceptable Limits of Chemical Exposure. Should PELs remain the benchmark? Continuous exposure to chemical emissions is known to impact our short and long-term health significantly. While we have set benchmarks known as PELs established by OSHA in 1970 based on TLVs from 1968 or earlier, these benchmarks are woefully outdated. However, the TSCA or EPA's OELs are a bit more updated. They too are not enough to ensure health and well-being within the workplace. Aside from the EPA and OSHA, ACGIH and NIOSH have established recommendations that are much more conservative and should be considered during your company's risk management policies. There are several solutions and additional safety measures we can implement to reduce exposure risks. One in particular is a way to treat the chemical throughout its life cycle with proper engineered controlled systems. Lab Manager likes our webinars to be very interactive, so we encourage you to submit your questions or comments to us at any point during today's webinar. Our speaker will address these questions during the question and answer session following his presentation. To ask a question or leave a comment, simply type your query into the Q&A box located on the upper right-hand side of your screen. We will try to address as many questions as possible during our time together, but if we happen to run out of time, I will forward any of your unanswered questions to today's speaker, and he can respond to you directly if possible. At this time, we also invite our live attendees to participate in our special poll where you can contribute your thoughts on safety for a chance to win a gift card. Additional resources for today's presentation are also located on the right-hand side of your screen in the handout section. The handout section also includes more information about our Lab Manager Academy management courses. I would like to remind you that the recording of this webinar will be available for free on-demand viewing after the conclusion of this event. And I would like to extend a special thank you to our sponsors whose support allows Lab Manager to keep these webinars free of charge for our readers. So with that, I'd like to introduce you to our presenter for this webinar. Jesse Coro, Director of Health and Healthcare at Erlab Inc., has over 20 years of experience providing solutions to the biopharma, pharmaceutical, medical device, and educational markets, with his specialty being focused on air filtration solutions for the protection of personnel, facilities, and the environment. Jesse also has experience working closely with hospitals, helping develop plans to adhere to USP 797 and USP 800 standards, while also providing solutions such as environmental monitoring, sterile processing, and proficiency testing. Jesse, thanks for joining us today.
Thank you, Mary Beth. It's truly a pleasure. I appreciate the opportunity this morning to present to you all at the Safety Summit. What really prompted me to provide this presentation was a discussion I had with a customer and their EH&S team, and what is most certainly a difference in philosophy on what should be the acceptable exposure limits. On one hand, their team was within compliance set by OSHA, and they were at or a little below threshold limit values of PELs. On the other hand, myself and my company, Erlab, we feel that any exposure is too much, and we must do everything we can to reduce those exposure limits to employees and other people within the facility. While I know the statement may make some cringe, it is a philosophy we stand by, as we know the significant impact it has to both our short and long-term health. So as part of our agenda today, we're going to talk about the engineered controls that are in place to help improve safety and reduce the level of exposure, and discuss certain PELs and how to reduce the exposure limits. I really want to do a comparison between NIOSH, OSHA, and ACGIH standards. And can there be a holistic approach to safety with filtration, detection, and communication, as well as other administrative controls that are put in place? And if filtration can be a solution, what are the safety standards we must put in place to ensure safety? And of course, I'll leave room for questions and answers after the presentation. So let's first discuss the engineered controls and the hierarchy of controls that are set by NIOSH. First, you have elimination. Can we eliminate the potential hazard? Can we substitute the potential hazard? And if we can't, how do we isolate people from these hazards? And we have to understand and implement proper administrative controls to change the way people work for optimal protection. And of course, PPE to protect workers. Now, we know some of these engineered controls in place are chemical ducted fume hoods or ductless filtering fume hoods, powder weighing stations, bulk powder stations, biosafety cabinets, downdraft tables, chemical storage cabinets. There's a lot of systems in place to, again, reduce the contamination concentration that people are exposed to. But again, is it enough? Are we truly providing the safest environment we can? Well, let's look at PELs exposures, and I call them exposures of the unknown. And these are just some chemicals that are most commonly used chemicals within the lab. And if you look at the discrepancies, you really see that there's quite a swing between what OSHA standards are to what NIOSH is and what ACGIH standards set. There's a discrepancies on almost every chemical. So again, should we use OSHA? Should we even use NIOSH? And should we even use ACGIH as the standard of measure to ensure the safety and well-being of those within the lab and outside the lab? This really builds upon the philosophy of exposure that we mentioned earlier. With such great discrepancies, we wonder, are these benchmarks enough? To me, we must establish ways to improve the level of exposure by reducing the level of exposure. Add to this what we have learned over the last 20 months through this unfortunate pandemic and how important indoor air quality really is. When we talk about indoor air quality, many of us have now been exposed to what is known as PM 2.5. And I mention this because it's critical. We breathe between 10 to 20 liters of air per minute. That's a lot of air we breathe to keep us alive. We're only as healthy as the air we breathe. So we must find ways to eliminate our exposure to PM 2.5, VOCs, and other chemical emissions present in the very same building we walk into every day and trust that the air we breathe is healthy. Many studies have been done during this pandemic to understand the overall exposure to PM 2.5 and linking it to COVID-19 infection and mortality rates. But it's not just COVID-19. It's other things such as chronic respiratory disease, asthma, heart attacks, bronchitis, other respiratory problems, short-term effects from headaches to skin irritation. I've seen this all when I've walked labs. I've had many discussions with lab technicians, lab managers, saying that I've never experienced headaches. I've never had skin problems before. I'm now an asthmatic. It's because of what they're exposed to every single day. And though we're below thresholds or just at thresholds, again, using that as our benchmark, it is not enough. We truly must go beyond compliance. We must improve safety within the workplace and beyond. Review your company's risk tolerance. Establish your own OELs based around your overall risk management policies and stay in the loop of new OELs under the TSCA. We must apply proper administrative controls. So again, going beyond compliance is for sure part of what we need to do as safety experts to ensure that when people come into our place of employment, that they are indeed safe and they are not going to experience short or long-term health effects. I have this next slide to kind of show some pictures of engineered controls that are put in place. And many of the issues, I mean, clearly, I've seen sashes opened all the way. I've seen people putting their head Case in point to the picture to the left, inside of the fume hood, which completely contradicts exactly what the fume hood is to do, is to create a barrier of the emissions to the employee. Fume hoods used as storage cabinets with a sash opened. This allows for reentrainment into the lab. Reentrainment, as per ASHRAE, states that you can have up to 20% of the TLV of reentrainment into that very lab. Then you have flammable cabinets. The majority of flammable cabinets installed in laboratories are not ducted up to the HVAC system. They don't have any administrative controls engineering controls, put into place to ensure that any emissions that are released inside this cabinet are mitigated before they're opened. In fact, when these very same cabinets are opened, they're exposing those who open it to tremendous concentration levels. High spikes, yes, well, it's for a short period of time. When you reopen these doors and you're exposed to those spikes in concentration, you don't know how it's going to react to certain individuals. And in addition, those very same emissions that you're trying to stop from entering into the facility enter back into the facility when you open up these doors. The chemical doesn't care. It's going to go to the path of least resistance. It's going to follow the airstream. So there's so many different levels of areas of exposure within labs. There has to be a better way. Now let's talk a little bit about once we do release emissions. And I'm talking specifically about fume hoods because that's one of the best engineered control systems in place to, again, provide a barrier of chemical risks to the employee within the facility. But those very same ducted fume hoods, many people assume that once the chemical is flushed out of the room through the fume hood and out the exhaust stack, there must be regulations in place, there must be filters, and we must be safe. Well, the EPA actually doesn't have any criteria. It allows 100% of the PEL or TLV of the chemical to be released at the exhaust stack of this fume hood, which means, where does it go? Where do these chemicals go that we're trying to protect ourselves from? Well, you have possible reentrainment, which actually occurs much more frequently than many think, to a building that's next to the very same building that you're blowing out emissions from, or to the very same building. And if you look at compensational fluid dynamics and the airflow that occur when you're releasing these emissions from the stack, you clearly see right from the EPA, you have issues. There's reentrainment that occurs. And now what we're trying to mitigate in regards to exposure, we're actually bringing back into the facility and not the laboratory, other areas within the facility that does not have the proper fresh air exchange rates. So when you're trying not to integrate's the wrong word, when you're trying not to have other chemicals being flushed to other areas of the facility, and you're trying to adhere to proper standards and guidelines and ensure that any air within the laboratory is not recirculated to any other area within the facility to keep others safe that do not work in the laboratory, it's counterintuitive. You're actually exposing others due to possible reentrainment. So let's look at a whole different approach. What if we could provide safety through the chemical's life cycle? What if we could establish a system within the laboratory that provides containment of chemicals, no matter how you're using them, whether you have a GPLC machine, a rotary evaporator, if you're storing chemicals, or any potential chemical that is released into the lab? What if you had a system that could clean up the air? While we know most laboratories have between 4 to 8, sometimes 6 to 20 air exchange rates per hour, sometimes that's even not enough for the amount of emissions are released. So what if we could establish a system throughout that laboratory that not only provides continuous filtration to reduce those exposure limits, but also detection capabilities to see when possible exposure to spikes in concentration exist, and then communicate that throughout the facility or to the EH&S director of potential hazards, potential spikes. Now, these spikes that are detected aren't at PEL thresholds. They're well below those limits because, again, The cumulative effects of continuous exposure has significant negative repercussions on our health. So you really want to provide a holistic approach to improving safety. Filtration provides many additional safety measures. Again, safety throughout the chemical's life cycle, as we mentioned. At-source containment can provide containment ventilated enclosures for powders, liquid handling, for equipment enclosures, real-time detection, communication, and reporting, safe storage with proper filtration, also integrated solutions that integrate onto existing flammable or acid cabinets, again, to mitigate the risk of those emissions and those high concentration loads hitting lab technicians in the face. All done through continuous filtration of fugitive emissions in the lab with a whole room air filtration system. Again, providing a holistic approach to safety. Yes, but is filtration really safe? I wouldn't be proposing it if it wasn't. We have been providing filtered solutions for the protection of laboratory personnel for over 50 years. We understand the risks associated with working in a laboratory. These are people that are developing technologies, novel technologies that will help improve our lives. So why don't we step up our game and ensure that their livelihood and their lives are improved and their safety is looked out for? That is our job. That's our obligation. And that's what we should do. And that's what we've been doing for over 50 years. But again, is it safe? And that's something that everybody needs to understand. How can filtration provide me safety? How can it ensure I'm so used to the traditional mindset of taking a ducted fume hood, connecting it to the HVAC system, and off it goes? How can we be sure that filtration, when it recirculates air back into the lab, is going to provide me safety? For some people, that doesn't resonate. So I'm throwing air back into the very lab I'm trying to take emissions out of. I need to guarantee that that filtration is going to be safe. Well, remember what I said earlier in the presentation. ASHRAE allows 20% of reentrainment back into that very same lab of chemicals with an ducted fume hood. When you use filtration, we consider 1% of the PEL to be too much exposure and too much reentrainment. That's at which point we consider the filters to be saturated. That's at which point we consider safety to be compromised. Let's take a step back and understand the safety measures behind ductless filtering fume hoods. And again, I'm mentioning this because it's one of the best engineered control systems in place today to create that precious barrier between the employee and the chemical. But what are the safety standards you have to adhere to if you are providing a ductless fume hood? This isn't a no-holds-bar approach. There are strict safety measures that have to be adhered to. Yes, we have to follow ASHRAE and ANSI guidelines, but more importantly, AFNOR NFX 15211, which is referenced by ANSI Z95, is the most critical standard when you're talking about a ductless fume hood. And it encompasses filtration, containment efficiency, airface velocity, and documentation of a chemical listing, a list of chemicals that can be used within the ductless fume hood. But let's take a deeper dive, peel back the onion to truly understand this standard. First, you must have documentation providing a list of chemicals which can be retained by the filtration. This chemical listing provides you not only a list of chemicals, which is comprised of over 750 chemicals tested under 6 different concentrations twice, represents thousands of chemicals and their families. We know the chemicals that our filters can retain. We know down to the molecular gram that we're able to capture within that filter before we've seen detectable release no greater than 1% of the TLV. Because we've done our due diligence and we've tested all of these chemicals within our filter cartridges, we can provide a certificate of validation of the handlings within the enclosure that provides a guarantee of the overall filter's life cycle, the performance of the filter. And all this information is also third-party validated by Intertek. But what does a guarantee of filter life cycle mean? Well, Additionally, we have between a 24 to 48 filter life cycle of our filter media. It's a pretty extensive filter lifespan. Many assume there's a misconception that ductless fume hoods can only be only used when I'm using small amounts of chemistry, media prep phase, nothing in organic chem lab, no recrystallization. I can't use it for my rotary evaporators, distillation, whatever the process is. The reality is filtration can be used for the majority of handlings performed in the lab. Not all of them, there are exceptions, but for the majority. And it really takes some work of understanding the chemical application and also some work for the customer to implement additional administrative control systems. But understand, when we say that the filter is going to last 24 to 48 months, we have to, as part of the AFNOR standard, adhere to normal operating phase, detection phase, and safety phase. 3 critical phases we have to provide guarantees. Now, this shows you a filter column. Some hoods have 6 of these separate columns. Some have 3, some have 4. It really depends on the size of the fume hood. But we're able to integrate through what's known as flex technology, a combination of filters, HEPA as a primary if you're using powders, carbon, fan module, and a secondary level of carbon filtration for backup redundancy. Or you can just have 2 levels of carbon. It really will depend on the handlings performed within the fume hood. But again, we have to adhere to these conditions. So what does normal operating phase mean? It means that emissions at the filter's exhaust must be lower than 1% of the TLV throughout the filter's life cycle. So again, if we say the filters are going to last 24 months, we guarantee that they'll never be released greater than 1% of the TLV of the cumulative chemicals used within that fume hood. Then we have to take it a step further. Now, we do have sensors built into the fan modules to detect spikes in concentration past the primary stage of filtration. The second phase is known as detection phase. During detection phase, it's when we've detected a spike in concentration. At this point, we still provide a guarantee, even at detection phase, that the still release no greater than 1% of the TLV at the filter's exhaust with backup redundancy. Then we must provide safety phase. This is at which point we've seen a spike in concentration continuously. Now, if we see a quick blip in the radar and that spike in concentration alerts us of such, but then it quickly remediates itself, there's no need to worry. Really, the concern is when we see a continuous spike in that in those concentration levels. That's at which point that we've used up precious residency sites within that first level of carbon filtration. And then when we've done this, now you're at safety phase and you've had a spill, right? Even during safety phase, you've used up a lot of residency sites within that first carbon filter. You've ignored the alerts from the fume hood. You've ignored the alerts from what's known as our eGuard web-based platform. And now you've had a spill. Even at safety phase, we provide a guarantee that there'll never be exposure greater than 50% of the TLV, still far above where we ever want to be. But again, if proper administrative controls aren't in place, that could possibly happen. We have not had a customer reach safety phase because there's backup redundancies built in. We have safety specialists on site that continuously manage and monitor all of our accounts to ensure that customers are replacing the filters as per recommendation. And we just perform simple follow-ups to ensure handlings haven't been changed. Or how are things running? Have you noticed any alerts on your fume hood? But in the event it happens, we do have that backup safety phase. Again, no greater than 50% of TLV for 1/12 of the filter life cycle. Now, with all this, we enrich the experience of safety with Smart Monitoring Operating System, which again is a web-based platform that allows you to either direct connect to the unit, to your laptop, or connect wirelessly to understand the performance thresholds, filtration efficiency, proper ventilation, and fan status. Are we achieving all of these things? Are we working at peak operational performance? If any of these things go into the red and any of these performance criteria are compromised, The unit will alert, as well as push notifications to the individual managing the safety of the laboratory. So, in summary, we must be proactive with compliance. We must improve safety standards with voluntary guidelines, right? Increase your overall guidelines. Don't just use OSHA's standards as the benchmark. Develop appropriate OELs based on your risk assessment and find ways to improve current engineered controlled systems. So with that, I'd like to thank you all, and I'll open it up to any questions.
Okay, great. Thanks very much, Jesse. We appreciate your presentation, and I'm going to leave Erlab and Jesse's contact information up here while we do the Q&A. That way, if you would like to reach out following this webinar, you will know how to get in touch with them. So again, Jesse, thanks for a great presentation. For those of you who want to leave a question or a comment, you can type it in the Q&A box located on the right-hand side of your screen. So please leave your question there, or please just leave a comment and let us know what you thought of this presentation and if you found the information useful. Also, as a reminder, Erlab has provided a handout in the handout section that's relevant to this webinar, so you can access it there and then download it before we end today. So Jesse, let's jump into the first question here. How do you meet safety standards for a fume hood?
Well, good question. As I mentioned in the presentation, there's a couple of safety standards we do have to adhere to. First is ASHRAE, which is same safety standard. It's called ASHRAE 110 that a ducted fume hood has to adhere to, same as a ductless fume hood. And that's basically ensuring proper containment. And then we have the AFNOR NFX 15211 standard, which is for ductless filtering fume hoods only. And that, again, addresses the filters and the performance of the filters to ensure we don't have any release at the filter's exhaust exceeding that 1% of the PEL threshold.
All right, great. Thank you. Here is another question from the audience. What are your means for detection?
We have two forms of detection. It's really going to depend on what we're looking for. We have an electrochemical sensor for formaldehydes and acids, and then we have a dry contact metal oxide sensor for VOCs. And again, really what these sensors are designed to do is to detect spikes in concentration present in the lab. Mainly for VOCs, we do have a lot of accounts very concerned with formaldehyde because ACGIH standards and the reduction of exposure down to 0.75 ppm, which is obviously extremely challenging to get to. So we had to adjust our sensor in order to detect those limits. So there's two forms of detection, really dependent upon what we're looking for.
Great, thanks very much. Here's another question. Is it possible to use filtration for formaldehyde handlings?
It is challenging, but it is possible. The way we do that is we actually will have to pre-treat the filter in order to adsorb formaldehyde effectively and efficiently, again, based on the standards that are set. Again, we have to be 1% of the set guidelines of the PEL. So 0.75 ppm, we have to be at 1% of that, no greater than at the filter's exhaust. So therefore, we do have to pre-treat the filter to adsorb formaldehyde, but it is possible and frequent.
Okay, great. Thanks very much. Here's another question, and it's pretty long, so if you need me to repeat it, just feel free to ask, and I will do so. I am in the process of creating my company's reproductive protection program for lab employees pregnant or who are trying to get pregnant. No limits seem to be written for a developing fetus. My lab is fortunate that we have 100% fresh air and 12 turnovers of air per hour in HVAC, plus additional fume hoods and appropriate PPE and admin safeguards. We still have to have employees consult a physician for any concerns or extra precautions or reasonable accommodations. Is there anything else that you can suggest to protect these employees?
For sure. I would assess the lab and first see if there's any areas of concern where you may be performing open bench chemistry, where you don't think you have proper containment and where possible emissions can be released. While you are fortunate to have those 12 turnovers or air change rates per hour, you still have concentration loads that people can be exposed to, especially if you don't have proper containment. So I would always look to see where I could improve containment of any exposed chemicals. That would be first and foremost. I've seen this. I've been in labs that have high levels of xylene use, histology and pathology labs. I've seen pregnant women, unfortunately, in front of fume hoods in the lab just absolutely stinks of xylene. Of course, my olfactor is not burnt out like many of these lab technicians. Unfortunately, they don't think they're being exposed, but they're at high levels of concentration, even with high levels of fresh air exchange rates. And the way to properly mitigate that, the best way you can is, again, through a proper containment device.
Great, thank you. We have another question here that says, at end of life, how are filters to be disposed of? Do they and the contaminants they contain go to a landfill, or are they incinerated?
Great question. They do not go to a landfill. The proper means of disposal is through incineration. We will take some filters back. We have a contract with Veolia Environmental Services, and they will then take the filters and incinerate them properly, or most of our customers have their own environmental service company that will take the filters with them as well. When they do get incinerated, the incinerators have to follow strict EPA guidelines, which means just as we do in regards to adhere to the AFNOR standard, they too have to adhere to a very similar standard within these incinerators, where they cannot see release greater than 1% of any TLV, which means of every 10,000 molecules, one could potentially be released. So it's a very safe process. In addition to that, they also contribute to 14 megawatts of electricity. Many people don't understand that. With the clean steam and flue gases that are generated, it contributes to additional electricity, which is a good tidbit of information. But great question.
Great, thanks for that answer. Here is another question. Are there any recycling programs where filters are emptied, cleaned, and reused?
No, it could be done. We've looked into it, but it's just too costly. It doesn't make sense. It can be done, but again, doesn't make sense, financially speaking.
Okay, great. Thank you. Here's another question that says, our health and safety department will not listen to us when we request ventilation from our flammable cabinets, continuously saying the levels are below limits. Any advice for combating this?
Oh, gosh. Basically how I started this presentation, right? It's a conversation. It's a difference in philosophy. I don't have the answer for that. I guess the best thing is for education and understanding the importance of not using these thresholds as a benchmark, because again, those exposure limits, though they're at that threshold limit or a little below, you're still exposed. So just continue to fight the good fight. It's the only thing I can say, and try to dig up information from the EPA, NIOSH, OSHA, the TSCA, the Toxic Substance Control Act, and how they're trying to adjust these PELs, because that's a problem that exists rather frequently and unfortunately. So unfortunately, I don't know what to tell you, but just try to get them to be a little bit more educated on the importance of reducing your level of exposure as much as possible.
Great, thank you. I think we have time for a few more questions here. Do you have a system that can detect aziridines or ethylamine in manufacturing plants?
For that, you would need a mini ray system or a PID detector. No, we do not have a system to detect that.
Okay, great, thanks. I think we have one more question here. Would you share your opinion on HEPA filter integrated face masks as a possible at-work protection means? Thanks.
So having HEPA filters inside of the face masks. It's going to depend on what you're doing in the laboratory. Again, you cannot allow these you don't want to allow these PPE devices, such as a face mask with HEPA filtration, to be your only means of defense. I've said it before, and I sound repetitive saying this. If there's toxicity of chemicals that you're working with that are significantly risky to your overall health, you must implement proper containment devices and control measures in place. While the face mask will work, you have to understand, if there's aerosolized anything in that lab, it's not just what you breathe in. It can go into your eyes, it can go into your skin. So again, the impact of exposure isn't always about what you breathe in, though it is quite critical. It's not always about what you breathe in. So again, containment, containment, containment.
All right, wonderful. Thanks so much. So this brings us to the end of this webinar. And again, I would like to remind you all that this webinar will be available on demand shortly following this live presentation. So Lab Manager will send you an email once the recording is available, or you can visit our event website at summit.labmanager.com/safety, which you could see on the bottom right of your screen right now. And we will post the video there once it's available. So on behalf of Lab Manager, I'd like to thank Jesse Coral for all the hard work he put into his presentation. And I would like to thank all of you for taking time out of your busy schedules to join us today. Once again, thank you to our sponsors, Erlab, the Baker Company, BioRaft, OHouse, and Young's Lab Consulting. Their support allows Lab Manager to keep these webinars free of charge for our readers. Finally, I would like to invite all of you to attend the other webinars offered by Lab Manager's Safety Digital Summit. Our next presentation, How to Effectively Communicate About Lab Safety Risks, will begin in just a little while at 12:30 p.m. Eastern, and we invite you to please join us. For more information on all of our upcoming or on-demand webinars, or to learn more about the latest tools and technologies for the laboratory, please visit our website at labmanager.com. We hope you can join us again. Thank you again to Jesse, and thank you to all of you for being part of our Safety Digital Summit, and we hope you have a great day.